So we're talking about the periodic table today. I'm Kayla.
I'm Susan. So the light orange are alkaline metals, the red are alkaline earth metals, the dark purple are transition metals, the dark green are metals, the light green are metalloids, the gray is non-metals, and you'll notice that hydrogen is at a different place than any of the other non-metals, and that's because it has different properties. The light blue are halogens, the dark blue are noble gases, actinides are the light purple, and lanthanides are the light orange.
So valence electrons are the electrons in an outer shell of an atom. They're important because they show the elements' bonding, behavior, stability, and reactivity.
The atomic mass is the weight of 1 mole worth of the element, and you find the atomic mass at the bottom of the square, and the atomic number is at the top, and the middle is the symbol, and the name is below the symbol, and these are all important as you go higher up in chemistry.
So the reactivity for metals, when the chemical reactivity decreases, it goes left to right, and chemical reactivity increases as you go down the table. And for non-metals, chemical reactivity increases left to right, and then chemical reactivity decreases as you go down the table.
Increases from left to right, and those gases do not have electronegativity because they have a full range of valence electrons. And then it decreases from top to bottom, and your alkaline metals have the lowest electronegativities.
So dry ice is a solid form of CO2. The carbon combines with oxygen because of the octet rule. Carbon wants to have a full outer shell, which 2 oxygen atom provides. Here is chemistry.
Hi, I'm Suzu, and we're doing a dry ice experiment. We already filled this tub halfway with water, and now we're going to put some dry ice in it. Make sure you're never holding it. It's very dangerous if you touch it. So we have tongs and we have gloves on. And then we're going to put things in it. Like this sticky ball to emphasize sticking with chemistry. And we're going to let it sit a while to get hard. And we're going to put other things in it, like this squishy. See how it squishes now? So after it goes in this, it's going to solidify. Pour ice to our mixture. And then I'm going to put some slime, because we're going to stick to chemistry. Smash them after we take them out. And now, we're going to smash our sticking with chemistry object with our hammer. It just exploded! Lots of fun experience with chemistry.
Poor guy.
We were able to freeze one side, so it perforated the side of it. And now, this is part 2, where we're just putting the dry ice in the water.
Okay, so I filled the glass about halfway. We're going to put the dry ice in. And dry ice is sublimating into CO2 gas,
Which makes this cool witching effect that is perfect for Halloween. If you want to have more fun, take a wet paper towel, put some soap on it, and lightly brush the top until you have a shine on top. And you'll make just one big giant bubble, so that you can feel like you're telling the future. And then you just have to wait for it to sublimate enough into the bubble to create a dome. So now that you have a dome, you can either play with it and make it jiggle, or you can pop it and have the witch's brew again. Woo! Which segues into our next experiment where we'll use bubbles to create a volcano. We filled up a vase with some water and we're going to drop a cube in. And then we're going to watch what happens when you put soap in. And it should fill the bubbles with nitrogen, and you're going to get this foam on top, and it's just going to keep going until you run out of CO2. Kind of like a little Look at it. This is why we have to try because it's going to be a really good mess.
The dry ice is sublimating into a gas to cause bubbles and it'll overflow. Okay, so this is part 4. You grab a latex glove and place a medium-sized piece of dry ice in it. We filled the glove up with probably halfway of water. Then you tie it
Rapidly.
Okay, so it's clearly inflated.
It's clearly supplemented. And if you stick with chemistry, you can do fun experiments like this too.
Bye!
Bye!